Assalamualaikum warahmatullahi wabarakatuh. I am from group 16. Today I will explain answer question 1 and 8. Question 1. A man riding a bicycle with velocity of 1.5 meter per second as shown in figure 1. At the same instant, the rear wheel with a radius of 0.5 meter has a clockwise angular velocity with W equal to 3 radians per second that slip at constant point A. A. In your opinion, why does this slipping? The answer is, in my opinion, this slipping occur because at the point of constant the rear wheel with the surface the velocity is not equal to 0. B. Calculate the velocity of point A. At the point A, this is a free body diagram. The rear wheel has shown this. With the velocity VB 1.5 -1 and anticlockwise with omega 3 radians per second. The radius is 0.5 meter at the point B with all A per B, and the velocity B is VB equal to 1.5 millimeter per second, and this is VA at the point A. At the point A is point of contact of the road. At the point B is center of bicycle rim. This is free body diagram for rear wheel that we are calculate for using the formula, which is VA minus VB equal to VAB. By using this concept of relative motion analysis of kinematic for velocity, which we describe as combination of translation and rotation. And for this term, to to using RA minus to RB equal to RA per B. This is term of relative position vector for RA per B. Then after this we get VA minus VB equal to VA per B. VA contain of velocity at point A, VB contain of velocity at point B. VA per B is velocity of point A which represent to B. Since the relative position VA per B represent effect for circular motion about B, the term can be expressed by the cross product, which VA per B equal to W X R A per B. Then they are formed to then they are equal to VA minus VB equal to W X R A per P. And then by using this equation, I have they have given is VA not are given, which is to find VB equal to 1.5 millimeter per second, negative 1. W equal to 3 radius per second, and RAB equal to 0.5 meter. Then insert for point given or value given to equation for this. VA minus to 1.5 millimeter per second, negative 1, equal to 3 radius per second times 0.5 meter, which is 3 radius per second involved for 3 radius and 0.5 that are given RAB. And then VA minus 1.5 meter second, negative 1, equal to 1.5 meter second, negative 1. Then VA equal to 1.5 meter second, negative 1 plus 1.5 meter second, negative 1. And the final answer is 3 meter per second, and the direction is to the right or positive. Hence, we prove it is proof for VA magnitude is higher than VB. Hence, slipping occur at point A, which is a proof that, in my opinion. That's all for question 1. Question 8. The 40 kilo flyway shown in figure 8 has a radius of gyration of k0 equal to 0.3 meter above its center of mass. If it's subject to a torque of m equal to 9 theta power of 1 per 2 Nm, where theta is in radian. A. Compute the mass moment of inertia of the flywheel about center of mass. Given it is R equal to 0.3, M equal to 40 kilogram. Using the formula, I naught equal to R square M equal to 0.3 square times 40 kilo equal to 3.6 kilogram m square. And then this is a free body diagram for this question. Y wake equal to mg, which is 14 times 9.81 kilogram equal to 392.4 Newton. And to the left is OX and up is OY. The using clockwise is M. This is a mass of moment of inertia of the flywheel. It is measure of distribution of its mass relative to a given axis. The mass moment is denoted by A naught and it's given for single particle of mass M. All is the case the flywheel, the square of the value radius of gyration is multiplied with the mass of the flywheel to obtain mass as inertia. B. Calculate the kinetic energy of the flywheel. Using the formula is 1 per 2 times I naught W square, and the given is from the A is I naught equal to 3.6 kilogram meter cube. Meter square. And the answer is 1 per 2 times 3.6 W square equal to 1.8 W square J. As explained for this, the kinetic energy of the turning objects is analogous to linear kinetic energy. It can be expressed in terms of moment of inertia for I, and the angular velocity is W. The total kinetic energy of an extant object can be expressed as the sum of the translation kinetic energy of the center of mass and the rotation kinetic energy about the center of mass for the flywheel, which includes for rotation the rotational work and angular acceleration is obtained from Newton's second law for acceleration, and have this answer. To the question C, the given is determine work done by torque, which is M. Using the formula is W equal to pi torque and theta, which is theta equal to 5 revolution times in 2 pi equal to 10 pi. And using the formula, W M equal to integrate M d theta equal to upper and lower pi 10 and 0, 9 theta power of 2 d theta. And for the integrate for this is 9 theta per 3 per 2 power of 3 per 2, and the upper and lower is 10 pi and 0, and for the answer is 9 per 3 per 2 times 10 pi power of 3 2, and this answer is 1056.52 joule. for the last question is solve for this angular using T1 plus total U1 minus 2 equal to T2, and can be simplified for E a total U1 minus 2 equal to T2 minus T1, and that's the given is 1056.52 joule equal to 1.8 W square. 1.8 W square equal to T2 minus T1, and accepted by E is 1.8 W square joule. And the final answer is W equal to 586.95 power root for 586.95, and the final answer is 24.227 radius per second. And the conclusion is for the flywheel which the rotate about n axis, every point on the object has n equal amount of the angular velocity. Angular velocity is the case in the define of the rate of change of angular displacement. In this equation, the theory of conservation of energy used to solve the last angular with work done as the initial energy and rotational kinetic energy as the final energy after rotation are made. The unknown for the W is solved at the end for the solve D question. And that's all for question 8.